Welcome, Hornets, and thank you for joining me today. We're going to be going over the classwork that we worked on in class today, working with our U-Substitution, specifically with the worksheets that were provided to us, U-Subbed with trig number 5 and U-Substitution with trig number 1. Okay, so on the screen, you'll notice I have some problems here. We're going to be doing numbers 5, 7, and 9. They were the ones that we did in class today. And this is for those individuals who were struggling and needed some more support. Hopefully this will help. Once we get done with these three, we're going to turn it over. We're going to take a look at the odd problems on the opposite side, and that was with the U-Substitution with trig number 1. So the first thing I want to do is recognize that inside of this cosine, I have this 3x to the fourth plus 4. Now I know that if I use the U-Substitution, u equals 3x to the fourth plus 4, when I take my derivative du dx, I'm going to get the 12x cubed, and I can see that right here. By moving the dx over to construct the differential, I'm now ready to do my U-Substitution, and I will have the integration for the cosine of u du. Now when I do this, I'm asking myself, well, what do I do to get that cosine? Well, we know that cosine is the derivative of sine, and if I'm working backward, I'm going to call this the sine, and I'm going to back substitute 3x to the fourth plus 4, and I'm going to remember to put my plus c. That is my answer for number 5. Let's take a look at number 7. Notice in number 7, we're looking right smack dab inside of that secant squared, and I am looking at u equaling the x squared plus 5. That means that the du is going to be 2x dx. When I look at this, I notice that I have too much. So I'm going to factor out the minus 2, which is not part of the du, and I'm going to call this secant squared u du. Now notice when I do this, I know that the derivative of tangent is secant squared. So by putting my antiderivative, tangent of u, back substituting u, x squared plus 5, making sure that I put my plus c, I have number 7. Number 9. Once again, look inside of the trig function, and you'll notice that we have 2x cubed plus 5. If u equals 2x cubed plus 5, then the du has to equal 6x squared, and move my dx behind, and I can see the differential. Alrighty, so now I'm going to go ahead and I'm going to do my substitutions. Cosine of u du. When I integrate, I'm looking at sine of u, 2x cubed, plus 5, plus c. Now we can check by taking our derivative, and we know that the derivative of sine is cosine, and so that does work. Let's go ahead and turn the page. We're now looking at trig substitution number 1, or substitution with trig number 1. This was the second worksheet that I gave you, or the back side of it. And as we saw in the previous worksheet, I'm looking for what's inside of the trig function and comparing it to what's outside. Now I know that negative 2 times 10x will give me that negative 20x, and the U-Substitution 5x squared minus 1 will give me du equal to 10x dx, made into a differential. I can then factor out the minus 2, and I'm looking at secant u tangent u du. We know that the derivative for secant u tangent u, or the derivative or the function that gave me as a derivative secant u tangent u, is the secant. So we're looking at negative 2 secant. We're going to back substitute 5x squared minus 1, and then don't forget plus c. That's number 1. Let's take a look at number 3. 5x to the fifth minus 1 is what my u is going to be. Notice that when I take the derivative of this, du is the 25x to the fourth dx, and that's what I see here. Substituting, I'm going to have the cosecant of u, cotangent of u, and I have du. I'm now looking at this as the integration, and I know that it's going to be a minus sign, or pardon, minus cosecant. So I have minus cosecant of u, 5x to the fifth minus 1, plus c. Notice that negative is needed because otherwise I won't get that positive. Number 5, let u equal x squared plus 3, then du is 2x dx. I have a minus 3 too much, so minus 3 integration of the cosecant squared of u du. Now when I do this, I'm looking at the cotangent, so I know that I'm dealing with 3 cotangent of u, and I'm back substituting. Don't forget your plus c. Then, number 7, we're taking a look at this, and we're taking the 5x cubed plus 2 as my u. That means that du is going to be 15x squared dx made into a differential, and that means that I'm going to factor out that negative, and I should have a 4. So negative 4 integration for the cosine of u du. Now we know that the derivative of sine gave me that cosine, so I'm looking at negative 4 sine, and I back substitute 5x cubed plus 2, the quantity plus c. And there's our number 7. This brings us to number 9. Let u equal that x squared minus 5. That means that du is going to be 2x dx, and I have a negative. So I want to factor out that negative so that I can look at this as the cosecant squared of u du, and now I end up with my cotangent, and I'm back substituting with the u, x squared minus 5 plus c. Alrighty, that is our worksheet that we did today in class. I hope this has helped you. If it has, please remember to click like. Otherwise, if you had a problem with it, please make sure you let me know what the issue was. Alrighty, thank you very much, everybody. Please have a very good and safe day. Take care and be safe. Thank you very much, and we will see you tomorrow. Be well, and once again, please be nice to each other. It is easy to be mean. Thank you.